Hello everyone. Today we continue to solve and to prepare for technical interviews for practical part, especially for fun companies as Google, Uber, and Facebook. And today we will check the new exercise, which is called daily temperature. This exercise is of type medium. And actually the idea of this task is that we have a list, and in this list, as you can see, we have different temperatures, and our main goal is to find out for each day how much days we need to wait until we will find warmer day. So for example, here you can see that this is first day, and on the first day we had very hot temperature, 73 degree, and in the next day you can see that the temperature is 74, which means that we just need to wait only one day in order to get more warmer temperature. So here is the result, let's say. Then we go and check the next day. Yeah, in that case again, on the next day we have 75. So we just need to wait only one day for more warmer temperature. But if, for example, we check the day number 3, we will see that we need to wait 1, 2, 3, 4 days until we will get warmer temperature. So that's the idea. Now I wanted to present you how algorithm is working in practice, more dynamic. So let's put here 0, 0, 0, 0. Now I'll explain you why we need all of that stuff, what is presented here. So first of all, here we have our list, our temperatures, yeah. So for day 1, 10, 11, for the second day, and so on. And below we have an array where we will store our results. So for initially all days, first day, second day, third day, and so on, we'll have here 0. And the idea is that if we will not find warmer day, so for example, if for day number 1 we will not find warmer day, here will remain 0. So it means that we haven't found any day which is warmer than first one. But if we will find, then we will replace 0 with the corresponding value. And stack. So again, stack is a data structure which is working by principle of last in, first out. And the idea is that the top element which will be placed in this stack will be less than values which are placed below. We will see it a little bit later, and I will explain with more details. But that's the overall idea. I hope it's clear. And now let's try to solve this exercise and to check how this algorithm is working in our practice. So we start with first element. This is the first element, so we don't compare it with something, and we place the index of this element inside our stack. So here we will have 0. Okay, and again, here is our array. We don't change this value for day number 1 because we still are searching for warmer day for first day. So here we kind of finished, and we go to the next second day, and we check if the second day is warmer than the day which we have in our stack. So we get our index is 0, and we check if its value is less than the current element. And if it is, then we need to find out. In our case, yeah, it is. So the second day is warmer than the first one. So we take index of the current element where we are now located, which is 1. We take the index from our stack, which we pop, yeah, which we already have done, and we subtract from 1 0. Why we are doing so? Just in order to find the distance between current element, which is greater than temperature, which we have extracted from our stack. So the value will be 1, which means that we have waited only 1 day in order to get more warmer day. So let's update the value inside our result array. Nice. And we place the index of the current element inside our stack because we still need to find warmer day for temperature from the second day. So we go to the next element. Now here we have temperature 8, and we want to check if this temperature is greater than the temperature from our stack, and we can see that 8 is greater than 11, which means that we still haven't found temperature which is warmer than 11, and we haven't found temperature, and we need to search the temperature which is greater than 8. So we place 2 inside our stack, and we move to the next element with index 3, and again we check if this value is greater than value from index 2, and we can see again that this value is not greater than value from index 2, which means that we haven't found warmer day for 8, we haven't found warmer day for 11, and we need to search warmer day for 6. And we place here index 3. And you may ask me why we just only checked the value from the index 2, but we haven't compared value from index 3 with value from index 1. And if you remember, I have said that in our stack we will have the top element will be the smallest one. Yeah. So the idea is that this element is less than element from the left. So the top element from the stack. Yeah. So 2 it was in our case. It means that all elements which are below also will be greater than the element with which we compared element from index 2, because 2 value from index 2 is the smallest one, and because of that, because we haven't found warmer day, we put index inside our stack and just move forward. Now we are on value 20 with index 4, and we check, is this value under index 4 greater than the temperature from index 3? And we can see that yeah, it is. So we remove the value from our stack, and we need to calculate the distance. How we are doing that? So we take the current index 4 and subtract index 3. So the result for day number 4 will be 1. So we needed to wait 1 day in order to get warmer day. Now check if the current value is greater than the value from the index 2, and we again can see that yes, it is. So we take the current index and subtract the index from the stack, and we get 2, which means that we needed to wait 2 days in order to get warmer day. And we remove it from our stack. Now we check if the current element is greater than element in our stack from index 1. And again, we can see that yes, it is. So we subtract from 4, 1, and we get 3, which means that we needed to wait 3 days in order to get warmer day. And now, because this is the last element, and we don't have any element to compare with, here we leave 0, which means that that we haven't found any temperature in the future which will be greater than 20. So also one thing, just to be sure that everything is clear. So for example, let's imagine here, okay, let's imagine that here we would have 74. Yeah, let's imagine. And 74 is not greater than 20, which means that here, instead of 3, we would have 0, because we haven't found in the future any temperature which is warmer than 78, for example. So that's the idea. Now let's proceed and check the implementation of this algorithm. So let's start step by step. And how we already defined, we will need first of all a stack where we will store indices of elements, of temperatures, for which we still haven't found the temperature which is greater. So let's create this stack. Our stack will hold integers. Okay, perfect. Now also we will need to create an array where we will hold how much days we need to wait until we will get warmer temperature. So it will be an array of integers, and let's call it result. And before that, we will need to know how much elements we have in our temperatures array, just in order to create and declare a size for our result, which should be the same with the size of the temperatures. So let's here declare a variable n where we will store the length of the temperatures array. Okay, perfect. So now the next step, when I iterate through a temperatures array, I need to perform some process, some logic, to write some logic in order to solve our task. So let's create a for loop. Simple, actually, for loop, simple for loop. We know exact number of iteration, n. Okay, perfect. So let's imagine that we start from the first element, and we want to put this element inside our stack. Actually, not the element, but the index of that element. So we want to push it. Okay, perfect. But this is for first element. If this element is not first one, it means that we need to check if this element is greater than the element temperature from the left, so the previous temperature. And for that, we will need to create while loop inside our for, because we will need to check if the current temperature is greater than all temperatures from our stack. So let's create here while, and let's first put a condition that we will perform this logic from inside of this block of code while stack is not empty. Which means that we will check if temperature from our stack are less than the current one until the stack is not empty. But this condition is not enough, because if you remember, I mentioned that it doesn't make any sense to check if current element is greater than the element from the stack if the top one is not, so if it's not less. So we will need to put here a condition that we will repeat this logic only in case if current element from temperatures, if the current temperature is greater, because if it's less, then it doesn't make any sense to execute validation for all elements, all temperatures from the stack. So let's put here a condition that if only if current temperature is greater than temperature from the stack, then we will perform the logic. And also I want to pay your attention to this method. So the difference is between pick and pop, that pick will get us the top element from the stack but will not delete it, while pop will get us the top element from the stack and will delete this. So what logic we want to perform? We so we have checked that the current element is greater than this one, so we need to find out the distance. So we need to find out how much days we were waiting in order to get warmer temperature, this temperature. So for that we need to extract the index of the top element from the stack. So let's do this. Let's call it previous index, and let's extract it from the stack, extract and delete. And now we want to calculate the distance. So we take the current index and subtract the index which we have extracted from the top of the stack. So this will be the distance, actually the days, the distance, how much we were waiting for the temperature which is greater than temperature from day under previous index, let's say. And we will need to update our answer actually result array for index previous index. Yeah, because we have discovered how much days we need to wait from previous index to I, yeah, in order to get the warmer temperature. And now we set, instead of 0, this value. And after this, when we will perform all the iterations, when we will do all our calculations, we can return our array with results. Let me check what does it say. So okay, so that's the idea. I hope it was clear. And now let's proceed and check the complexity. Also, I have noticed that here I have committed a mistake, because we need to have and but not or, because this condition should work together, because if let's imagine if this condition is not true, which means that our stack is empty, it's not possible to execute this validation, because here we need the value from the stack. Yeah, so we get the top element from the stack, so it's not possible to take the top element of a stack if stack is empty. So that's why we put here and condition operator, but not or. So now let's check the complexity. So the time complexity for this algorithm is ON, and the space complexity also is ON. So I hope everything was clear, and we will see in the next video. Bye.